first thing it asks us is to find the acceleration of the particle at t equals 3. Right? We know that acceleration is the derivative of velocity. So to find the acceleration at 3, all you need is v prime of 3. And literally, all you have to write is v prime of 3 equals. And then put your answer, right? Your calculator will do the rest for you. And it says that that came out to be negative 2.118. Easy enough. Hopefully that first part was pretty straightforward. Yeah. They gave you 1 point for that.
Mr. Batchelor?
Yeah.
So do we have to write the equation here, or is it okay to just put v prime?
V prime of 3 equals is good enough. You do not need to write, the derivative of 10 sine 0.4 t squared over t squared minus t plus 3 at 3 is, no, you don't need to write any of that. Just v prime of 3 equals. And that's exactly what they write on the scoring guide. And then I even have like some student samples below. And the person that they said got full points literally wrote this. They had a fourth number on there, but like, whatever, we don't need that. Literally.
Okay,
yep.
So this is a calculator question. Is there a way to, like, once you put it into the y equals window, is that like pre-saved and you can just click like derivative of this function that I already have put in, or do I need to do derivative of and then type it out?
No, you can do it from the graph screen if you've graphed it first. If you've already graphed it, one second, let me finish answering this question. Yeah. So if you've already graphed it, when you are in the graph window, hit second, and then it's the same calculate window. It's like second trace, I think is what it is. The same one that has like x-intercept and intersection point and all that. Second calculate. And then somewhere down there on that list, I think it might be option 6, is dy dx or d dx or something like that. Do you see it in there?
Yeah, it was number 6.
It was number 6?
Yes.
Wonderful, yeah. And so then it'll just pop up a window. It'll say like x equals, and you just type in 3 and hit enter, and then it'll give you the answer. Did that work?
Thank you. That makes my life a lot easier.
Yeah, no problem. Yeah, you all got that. You can do the derivative from the graph. You don't have to go back and retype it if you've already graphed it. Question asked? Like of some function that was like that? Yeah, potentially. My guess is that's a little more complicated than they would ask you to just write out a derivative of, but potentially. I mean, you just use the quotient rule, right? And then for the top part, when you find the derivative of the top part, you'd have to use the chain rule, but chances are no. And they certainly wouldn't ask you to evaluate the derivative of that at something unless it was like a really easy value to plug in, like 0 or something like that. So, without a calculator. All right, everybody good there? All right, part B, find the position of the particle at t equals 3. Well, we have velocity, so how do we find the displacement if we have velocity?
Second derivative?
No, second derivative will be acceleration. We want displacement. We want a change in position. So we need to go and integrate this function to go from velocity to position. So if we integrate this from 0 to 3, that should tell us how far the particle moves from its starting position, like what its displacement is from the starting position after those 3 seconds. Now, that's not going to give us the actual position, though. That's just telling us how much its position has changed. So we have to add to that the initial location of the particle, which was -5. So -5 plus this displacement should give you your answer, which came out to be -1.760. How many of you got that?
Yeah.
Yeah? Oh, good.
Yeah.
Yeah. Now, if they had said that the particle is at position x equals -5 at time t equals 1, instead of integrating from 0 to 3, I would then integrate from 1 to 3, right? If it said x equals 3 at t equals 2, I'd have 3 plus the integral from 2 to 3. Everybody good with that? Okay, that one is worth 3 points. 1 point if you have the right integral, 1 point if you remember the initial condition, and 1 point if you have the correct actual answer. Okay? So make sure that if you are looking for displacement or position of the particle, that you include the initial condition within that. If you don't include that, you're only going to end up with one of those 3 points. Yeah. Question?
Like, when do you go like consider like whatever is that in there? You have to write down like the initial
No, we normally wrote those for like the rate problems where we're then taking the derivative back of it, but in this case, we're not doing it. Everybody good with that question, Ryan? Yep. From the integral of that equation from 0 to 3. I mean, the -5 is not within the integral though. It's the integral and then you add the -5 to it. Because the integral tells you how much the particle moves, right? The integral of it from 0 to 3 is the displacement. So that's how much it moves, and then we have to say, well, it moved from a position of -5 this much, so it's at this position. All right, so, I mean, you know, we could write that this way. This is where it started. Where it started plus the displacement ought to equal the position, right? I mean, that's, you know, wherever I started plus how much I moved is where I am. And if I start here and move 20 feet, I'm over at the door, right? I've moved 20 feet, right? That's what this is. Does that make sense to everybody? Okay. All right, part C, evaluate the integral from 0 to 3.5 of v of t and the integral from 0 to 3.5 of the absolute value of v of t. So those should both be pretty easy to do. The first one comes out to just be 2.844. That should be pretty easy. The second one comes out to be 3.737. Hopefully you got those just by plugging them into your calculator. That should be easy enough. Getting both of those values is 1 point. And then the explanation, what is the meaning of each of those, is worth 2 points total. So 1 for each of them. The value 2.844, that was 2.844, yeah. The integral from 0 to 3.5 of v of t. Well, when you integrate velocity, what do you get? You get the well, it's not the position. It's only the position if you add an initial point to it. So the integral itself is just the displacement. So you'd write out this is the displacement of the particle from 0 to 3.5 seconds. That's all that is. What is the integral of the absolute value of velocity? What is absolute value of velocity? This is speed, right? Something we've talked about before, the absolute value of velocity is speed. And you integrate speed to get the total distance traveled, right? Which is different from the displacement if it's ever moving, you know, back and forth, right? Instead of just moving to the right, if it moves to the left some, the displacement's getting smaller, but you're still traveling some distance. So this is total distance traveled on 0 to 3.5. Did they not say seconds? Yeah, okay, sorry. Usually they no seconds added there. You don't need to say from t equals 0 to t equals 0. From 0 to 3.5 or from t equals 0 to t. So either way, it's fine. Any questions on part C? So remember that total distance, and this shows up all the time. Total distance traveled is the integral of speed, absolute value of velocity, and then integrate. And you'll have to use your calculator to do that. Okay. Part D, we have a second particle that moves along the x-axis. We are given its position equation. And we want to know when the two particles are moving with the same velocity. Well, we want v of t, then, the velocity of our first one, to be equal to the velocity of the second, which is the derivative of its position, right? What's the derivative of that position? The position was t squared minus t. So that would be 2t minus 1. So you're setting your original equation, what was it, 10 sine 0.4 t squared over t squared minus t plus 3 equal to 2t minus 1. All right, so what was it, 10 sine of 0.4 t squared? You don't need to write all this out. Over t squared minus t plus 3. And then you just use the two graphs on your graphing calculator and calculate where they intersect. And it came out to be that happens at t equals 1.571. And that was worth 2 points. One for setting v of t equal to the derivative here, and 1 point for the answer. Everybody good with that? Leopold, you'll be able to do that tomorrow? Oh, good. Everybody else, you'll be able to do that in a few weeks or a month. Something like that. Any questions on that? Zoom people, are you good or no?
All good.
Cool.
Oh, good. Wonderful. All right. Let's work through this one together because we're somehow only have 20 minutes left already. Is that right? 04 is when we get out of here? Yeah, all right. Let's work through this one then. So a non-calculator motion problem. We got two particles moving along the x-axis from 0 to 8. We're given the position of particle P, and we're given the velocity of particle Q. We're also given an initial position for particle Q, right? That at t equals 0, it's at a position of 5. Right? So from t equals 0 to t equals 8, we want to know when this particle P moving to the left. Well, a particle moves to the left if its derivative is, if the derivative of its position is what? If it's less than 0, right? Negative velocity means moving to the left. So we want to take the derivative of natural log of t squared minus 2t plus 10 and figure out when that is negative. So what's the derivative of natural log of t squared minus 2t plus 10? It should be 1 over t squared minus 2t plus 10 times the derivative of t squared minus 2t plus 10, which is 2t minus 2. Everybody good there? Good. All right, so let's move on then. What do we need to do here? We need to figure out when this is negative. So how do we do that? Figure out based on the numerator when it might be 0 or the denominator when it might be undefined. So numerator equals 0 when t equals 1, and the denominator equals 0 when is that equal to 0? Can you factor that? No. If you take the discriminant, we see that b squared minus 4ac, the piece inside the square root, is less than 0, the piece inside the square root on the quadratic formula. So there's no real solutions from that. So t equals 1 is the only place where it's going to change directions. So then we'll put t equals 1 on here. We'll put 0 and 8 just to make sure we don't plug any values outside of 0 and 8 because that's what our interval of time is. If you plug in something between 0 and 1 to your derivative, what do you end up getting? The denominator is going to be positive, and the numerator is going to be negative, so it's moving to the left, or the value of the position is decreasing. And if we plug in something between 1 and 8, like 6, top's going to be positive and the bottom's going to be positive. So it's moving to the right. So this is left. This is right. So it ought to be moving left from t equals 0 to t equals 1. I was going to pull up this. Let me pull up the scoring guidelines and tell me how many points that's worth. Everybody good with that one? Any questions, Zoom or otherwise? Okay. That was worth 2 points. So 1 for correctly getting the derivative and 1 for the answer. All right, part B. We want to find all times during which the two particles travel in the same direction. All right, so we know that particle P is left, 0 to 1, right, 1 to 8, right? We need to then figure out about particle Q. Particle Q, the velocity of Q was t squared minus 8t plus 15. So we want to know when is that velocity positive and when is that velocity negative. So set it equal to 0 and factor t minus 3, t minus 5 equals 0. And so it can only change signs at 3 and 5. And so we'll just test the values of the velocity between 0 and 3, 3 and 5, and 5 and 8. That makes sense to everybody? Yeah. So between 0 and 3, like 1, this is negative times a negative. So it's moving to the right. Between 3 and 5, like 4, this is positive and negative. So you multiply those, you get a negative. So it's moving left. And then from 5 to 8, like 6, you get a positive and a positive. So it's moving back to the right. So particle P is moving left from 0 to 1, but particle Q is not. So that's not the same. From 2 to 3, though, they're both moving to the right. Y'all agree with that? No, 1 to 3. Did I say 2 to 3? 1 to 3. And then from 3 to 5, this one's moving left, but this one's moving right. But from 5 to 8, they're both moving to the right. So from t equals 1 to t equals 3, and from t equals 5 to t equals 8. And they gave you 2 points for that. 1 for having the intervals and 1 for some analysis. You know, all this work right here is worth 1 point as well, to show when it's moving left and when it's moving right. Everybody good there? Leopold good with that? Okay. Cool. Everybody's good? All right. Next part. Part C, find the acceleration of Q at t equals 2. All right, so that should be easy enough. How do we find the acceleration of Q? We take the derivative of the velocity. So v sub q prime of 2 ought to be a sub q of 2. And what was the derivative? It was 2t, it was t squared minus 8t, right? Plus 15, all right? So 2t minus 8. And we'll evaluate that at t equals 2, which is negative 4. That's the first part of that question. They gave you 1 point for getting that value. Everybody good with that? That part should be pretty easy. Take the derivative to get acceleration. The second thing it asks was about if the speed, not the velocity, if the speed of the particle is increasing, decreasing, or neither at t equals 2. So speed is increasing if what is true? Something we talked about a while back. If velocity and acceleration have the same sign. So if velocity and acceleration are both positive, the speed is increasing. If velocity and acceleration are both negative, the speed is increasing. Okay. Speed decreases if velocity and acceleration have different signs. One's positive and the other's negative. That is something you need to know and have memorized. Yeah. Why is that? Because if the velocity is positive and the acceleration is positive, it's getting faster, so the speed would be increasing, right? If the velocity is negative and the acceleration is negative, that means, let's suppose we have a velocity of -5, but the acceleration is negative. That means it's going up to like -6, then -7 velocity, -8 velocity. And speed is the absolute value of that. So take the absolute value of those 5 to 6 to 7 to 8, it's getting faster. But if they have opposite signs, it's doing the other. It's going the other. Does that make sense? Everybody good with that? Yeah? Okay. So we know that the acceleration is negative. We need to figure out what is v sub q of 2, right? To figure out if the velocity and the acceleration have same or different signs. So v sub q of 2 is 2 squared minus 8 times 2. That's a t, not a 2. Plus 15, right? That was v sub q. So what is that? 4 minus 16 plus 15. 4 minus 16 plus 15 is greater than 0. True? So negative, positive. We would say velocity and acceleration have different signs. Speed decreases. And speed is decreasing with an explanation is worth another point. Everybody good with that? I think you've had enough shutting your laptop down. Yeah. I don't blame you. Everyone good with that? All right. And then there was another part here, right? Part G. Find the position of particle Q the first time it changes directions. Okay. So we go back and we want to find out, when does Q change directions? Well, we already figured that out, right? What's the first time that Q changes directions? There was Q. It was moving right from 0 to 3. Then it was moving left from 3 to 5. So it must change directions first at t equals 3. Everybody good with that? We want to find the position of particle Q at t equals 3, which means we need to do what? We need to integrate the velocity of Q from whatever our initial condition is to 3 to find the displacement. I think they told us a position at t equals 0. Right, at t equals 0, particle Q is at position of 5. So the integral itself gives us the displacement. We need to also add in the initial condition. So where it started plus the displacement should equal the final position. Does that make sense to everybody? So we have 5 plus the integral from 0 to 3 of t squared minus 8t plus 15 dt. This time you got to do it by hand because you don't have a calculator, and that's fine because it's a fairly easy integral, right? T cubed over 3 minus 4t squared plus 15t from 0 to 3. Conveniently, when you plug in 0 for your lower limit, those are all 0. So we've just got 5 plus 3 cubed is 27 over 3 is 9. Minus 4 times 9 is 36. Plus 15 times 3 is 45. So I don't know, what does that come out to be? 23? Hopefully I did that. Yeah, that was the right arithmetic. Oh, good. 3 points for that one. So 1 point if you use the antiderivative, 1 point, actually that's not true. 1 point if you have the correct antiderivative, 1 point if you remember the initial condition, and 1 point for the final answer. You had to actually correctly integrate to get one of the points. Any questions on that one? Fairly similar to the last one. You'll find that most of the motion problems are fairly similar, whether they're calculator or not. They're not necessarily all about particles moving in a line, It might be, instead of being a particle moving in a line, it might be about some person jogging along a straight path, right? Or it might be about a train running back and forth on a railroad track. But they're all going to be about the motion of something in the back and forth, left, right, or it might be up and down direction, but same thing, right? Same basic concept. Does that make sense to everybody? All of you people at home too, are you good with that? Okay. This week's quiz is going to be on motion problems. This week's quiz is going to be on motion problems, specifically motion problems. That's the only free response type on this quiz. Right. I will be working diligently this week to get your quizzes all graded and inputted now that the AP test for some people is tomorrow and I don't have to worry about, 2-hour review sessions every night. So I've been going back and forth with A, B, and B, C different days. So you guys have one more review session today. So hopefully many of you will be there. Leopold, hopefully you'll be there since you're taking the test tomorrow. 7 to 9 tonight. It's the best I can do because my kid doesn't get done with baseball till 6 o'clock. So 7 o'clock, it gives me time to like shove food at my children before I can start doing it. Any questions on anything?